Hello guys, you're most welcome to Electrolysis, and today we are going to look at electrolysis of dilute copper to sulphate, and we are going to understand what I was supposed to consider and how I can do this at home, or how I can do this. Let's go. So here with me I have the graphite electrodes extracted from the dry cells, perhaps those ones which are old, and they are going to work as the anode and the cathode. This one I'm holding right here, and what I'm going to do, I'm going to dip them into my copper to sulphate solution, and I'm going to use a crocodile clip to grab it next to the beaker. Then like this, I'm going to fix it to be firm. Then I connect also another one. Then I'm going to tell you which one is the anode and which one is the cathode. So here with me now, I've already dipped them. Now the dry cells, this is my switch and the dry cells are here. So I want to show you that this is the positive terminal, this positive terminal. So it's going to the switch, then it means this electrode here is what we call the anode. So now that this is the negative, so to run to it to make the cathode, it will go and make connection to the cathode. So what I'm going to do is that before I close the switch, nothing will happen, and the moment I close the switch, then the reaction is going to start. Remember, electrolytic cells consume electric current to carry out electrolysis, whereas the other EMF cells, for them they will carry out electrolysis to give off current. So we are seeing that at the anode, this side we are seeing the bubbles. Where you see the bubbles, that is the anode, and those bubbles, that is bubbles of a colorless gas, and that is our oxygen being formed there. And we don't happen to see any bubble at the cathode, because what we are also formed there is not any gas. And I think when you consider the position of these elements in the activity theory, you know that copper is below hydrogen, so we cannot discharge hydrogen at the cathode, but we shall discharge copper preferentially, or in preference to hydrogen. So how are we going to do this? We are going to observe up to the end so that we see what we are going to form there at the cathode, and we are already seeing the product at the anode. So it requires some bit of patience, and sometimes you have to increase the power. As you look at mine, I used 2 dry cells at first, but when I realized copper was not forming very fast, I had to increase the number of dry cells so that the increase on the electricity being used so as to discharge the copper at the cathode very fast, so that we can see it. And as we're seeing here, then we shall see what we are going to observe at last. But don't forget to subscribe to Rio Science Pal. For more videos are still coming. Please subscribe. At the cathode, we are having copper being deposited there, and we know that copper is a brown solid. You can see that this is a brown solid being formed there, and this is copper being deposited there, because copper is below hydrogen, the activity theory. And if I remove this electrode, these are graphite electrodes, we shall not have further production of oxygen even at the anode, because the circuit is going to be non-complete. So if I return it, I'll be having some more bubbles of oxygen being produced, though they are not very many. So we can see some bubbles being produced, because we know that graphite conducts electricity because of the free mobile electron. And why this copper to sulphate conducts electricity is because of the free moving ion, not electron. So if I remove it, no more production of bubbles goes on. If I return, so you can have the bubbles being produced.